Welcome to this channel, and in this video we're going to be looking at trigonometry maths 101. Right, so let's get right in. So considering a right angle triangle, right, and here is 90 degrees, let's call this side A, this side B, and this side C, and then let's call here theta. Right, okay. So from previous knowledge, I guess you should know that the sine of the angle, you have the cos of the angle and the tan of the angle. So in the case of sine theta, it's simply the opposite side over the hypotenuse, and then in this case the adjacent side over the hypotenuse, and then in this case the opposite side divided by the adjacent. So in this case the opposite is B and the hypotenuse is C, and then for cos theta we have A, because A is adjacent to theta, that's A over C, and then opposite over adjacent, that's B over A. So these are the three basic trigonometric ratios you are expected to know. And if you look carefully at what we've derived, first of all we said that sine theta is equal to what? B over C, because B is the opposite, C is the hypotenuse, which is the longest side of the triangle. So sine theta is this, cos theta is this, that's A over C, and tan theta is this. If you look carefully, you would see that sine theta over cos theta is equal to tan theta. Please take very careful about this, right? Sine theta over cos theta is equal to tan theta is a very important identity for you to know, right? Because by the time we have B over C, which is sine theta, and A over C, which is cos theta, and then if we should divide it, B over C divided by A over C will be equal to B over C times C over A, which is still B over A, which is tan theta, right? So very important identity. Another important identity you need to know for the exam is the fact that sine squared theta plus cos squared theta is equal to 1. Prior to what I said earlier, we said that sine theta is equal to B over C, right? And the fact that cos theta is equal to A over C. So if we should get sine squared theta is simply going to be B over C all squared plus A over C all squared, which is going to be B squared over C squared plus A squared over C squared, which is going to be B squared plus A squared over C squared. And you can see that this is a right angle triangle, and according to the Pythagoras theorem, says that C squared, which is the hypotenuse, is equal to A squared plus B squared, right? So we can then replace B squared plus A squared with what? C squared, and that will be C squared over C squared, which is 1. So we can then comfortably say that sine squared theta plus cos squared theta is equal to 1. And then another important identity is fact that 1 plus tan square x is equal to sec square x, and that then leads me to the other three quantities that are very crucial. And it's the fact that we don't just have sine theta, cos theta, and tan theta, we also have their inverses, right? So for sine theta, if we have the inverse of sine theta, it's equal to cosec theta. Then if it's for cos theta, if we have to get the inverse of cos theta, which is 1 over cos theta, we have sec theta. And then for tan theta, 1 over tan theta is equal to cot theta. Do you understand? Okay, so in this case I mentioned that 1 plus tan squared x is equal to what? Sec squared x. So since we mentioned earlier, according to the triangle drawn that I've drawn, we said that tan theta is equal to B over A. So if we then get 1 plus B over A all squared, which corresponds to tan squared x, 1 plus B over A all squared, it will be equal to 1 plus B squared over A squared, right? And then if we should simplify this, what are we going to have? It's going to be A squared, and then to be A squared plus B squared. And A squared plus B squared is what? Is C squared according to Pythagoras theorem, right? And then that's C squared over A squared which is what? C over A all squared. And C over A is equal to what? Sec x. Why is C over A equal to sec x? Because from what we derived, we said that cos theta is equal to what? A over C. And I've said it that sec theta is equal to the inverse of cos, right? So 1 plus tan square x is equal to sec square x. The same principle applies. 1 plus cot square x is equal to what? Cosec square x, which implies 1 plus tan 1 plus 1 over tan x all squared, because cot x is 1 over tan x, is equal to 1 over sin x all squared. Same principle. So let's go further. It's important that you know the meaning of the term complementary angles and how you can apply it to solve some problems. So when you're talking about complementary angles, you're talking of angles that add up together to have 90 degrees. So still considering the previous triangle, this is 90 degrees, right? This is theta. And remember that the sum of angles in the triangle is 180 degrees, right? So we're gonna have 180 minus theta plus, this is a right angle, plus 90, and then we're left with what? 90 minus theta. So here is 90 minus theta. So you can see that the sum of this angle and this angle sums to 90 degrees. And then that still brings us to some further investigation. This is A, this is B, and this is C, right? So now sine theta, which is what? B over C, is equal to cos 90 minus what? Theta. From this now, how do we then show that this is true? Sine theta is what? B over C. And cos 90 minus theta, what is the which side of this triangle is adjacent to 90 minus theta? Is B, right? So it's still B over what? C. Do you understand? And then in the case of sine 90 minus theta, that means what is opposite? It will be equal to what? Cos theta. Sine 90 minus theta is what? A over C. And cos theta is also what? A over C. Do you understand? So you can see that sine and cos are complementary. That is where you can express them just like so. We've established the fact that sine theta is equal to cos 90 minus theta. That's why you could comfortably say that cos 30 is equal to what? Sine 90 minus 30, which is equal to what? Sine 60 degrees. You understand the complementary we are talking about here? Okay, and then the same thing applies to the tan. Looking at this triangle now, if you want to derive tan theta is equal to what? B over A, right? Because that's opposite over adjacent. And then what is the value of cot theta? What is the value of cot theta? Cot theta is equal to what? A over B. But we could also establish the fact that tan 90 minus theta will be equal to what? Cot theta. If we should get what tan 90 minus theta is, what side of the triangle is opposite to 90 minus theta? It's A, right? And then what side is adjacent to 90 minus theta? It's what? B. So this is another complementary set of complementary angles. So you could also say that tan 90 minus theta is equal to cot theta, or you could say that cot 90 minus theta is equal to what? Tan theta. So with that, we have tan 60 degrees is the same as cot 30 degrees, right? Okay, let's move fast. Okay, then we move to what we call the quadrants, and these are different sectors in the space that allow certain sets of angles. So taking the quadrants, this is the first, because this is a kind of like an anti-clockwise movement, that is in this direction. Starting from here, this is 90 degrees, this is 90, this is 90, this is 90. So this is the first quadrant, this is the second quadrant, this is the third, because remember we are moving like this, right? And then this is the fourth. So one important thing to note here is mastering the regions where each of the fundamental trig quantities we've discussed. We've talked about sine theta, we've talked about cos theta, and we've talked about tan theta. There are certain regions where they are positive, where they are negative, right? And where all of them are positive. It's important to note that in the first quadrant, right, all these trig ratios are positive, right? And this first quadrant, we are starting from what? 0 to 90 degrees. Are you following? This is the first quadrant from 0 to 90. So within this range, sine, cos, and tan are positive. Very important. And then when on moving to the second quadrant, 90 degrees to 180 degrees, only sine is positive, cos and tan are negative. Right, all these are proved is proved from graphs. And then tan is also negative. Then moving to the third quadrant, tan is positive, while the others cos negative, and sine is also negative. And then moving to the fourth quadrant, cos is positive, sine is negative, tan is negative. So how do you remember this? Because I've seen some past questions on the exam where they could give you something and expect you to locate what quadrant it belongs to. So I would advise you do this. Draw this, understanding that this is an anti-clockwise movement. What you're just going to have here is first, second, third, fourth, right? And then you simply place A, C, T, S, acts, right? In this direction. You see the way I place it, A, C, T, S. So that you know that once you see A, it means all. That means all is positive, all are positive. S, you're talking about sine, you're talking about tan being positive, sine being positive, and cos being positive in this region. Are you following? And then we said 90 to 180 here in the second. From the third, we have 180 to 270. And then in the fourth, we have 270 to 360 degrees, which is a total complete revolution. Okay, let us go further and let's look at an important concept, and this is very important, and it's the fact it's still based on what we've been saying. Remember I said that all is positive here, all are positive here, right? And then we have ACTS, right? So it's important to note that if we should draw something over here, and then we have an angle theta, follow me, and then we have another angle here, theta. It's important to know that sine of negative theta is equal to negative sine theta. The cos of negative theta is equal to cos theta, and the tan of negative theta is equal to negative tan theta. Right? So these two, very important. Then you should then note that the cos of negative theta is still going to give you what? Cos theta. So you can comfortably say that cos of negative 30 degrees is what? Cos 30. Are you following? So in this case now, I'm trying to explain this with this diagram over here. This is positive theta and this is negative theta. So you see that in this region, cos is what's positive. So regardless of whether the angle is negative, you're going to have a positive result. But you can see that all others which lie, this lies in the second quadrant, this lies in the third quadrant, are negative, right? That's based in this region, in this particular region, negative theta. We're looking at negative theta, right? Okay, very important. We build. Okay, let's look at conversions. It's very crucial for the exam. You should know how to convert from radians to degrees and from degrees to radians. And all this started from a simple concept. You have a circle with a center, alright, and then with radius r, and then you have that the length of this arc, because this is an arc, right? This is an arc. This line over here, this curve over here, this is an arc, and then the length of that arc is also r. And if you studied circles and circular measurements, you know that the length of an arc is given as theta over 360 times 2 pi r. Are you following? And in this case, the length of this arc is what? This. And then let's say that here is theta, and then we draw something over here. So if we should then increase this angle, to 180 degrees, we'll find out that the length of the arc generated according to this formula will be what? 180 over 360 times 2 pi r, which is going to give us what? Pi r. So that led to something. We now establish the fact that in a system where you have this is radii, and then the length of the arc is also equal to the radii, right? We now have that this angle in between is what? Is a radian. So 1 radian multiplied by pi, because you can see that this was the initial value, right? R, which was the length of arc. But when the angle was now increased to 180 degrees, what happened? It now became pi r. So we can confidently say that 1 radian multiplied by pi, we scaled it up to 180 degrees. 1 radian multiplied by pi is equal to what? 180 degrees. And that leads to the fact that 1 radian is equal to what? 180 over pi. Do you get? So let's say I'm given this question, pi over 3, and you have to convert it to what? Let me get a question. Yeah, let's use that. Pi over 3 radians. And you have to convert it to degrees. What are you simply going to do? It's simply going to be what? Pi over 3 multiplied by what? 180 over pi. And this is going to cancel this. 180 divided by 3 is what? That's 60 degrees. Do you understand? And then I want you to pause the video. When I write this down, I want you to convert the radian to what? Degrees. So let's say I'm given this 5 over 2 pi. Pause the video and convert it to degrees. That's simply going to be what? 5 over 2 pi times 180 over pi. This cancels this, and then we have 2 into itself 1, and then we have 90, and then that's 450 degrees. Do you understand? So let's say you're asked in the exam to convert from degrees to radians. Remember, I will say that 1 radian multiplied by pi is equal to 180 degrees. Hence, 1 degree will be equal to x. Let's say 1 degree is equal to x. So we cross multiply. We now have that x pi is equal to 180 times 1. So we can say that x is equal to what? Is equal to 180. So since 1 radian, sorry, I misaligned this. Since 1 radian is equal to 180, that's times pi is equal to 180 degrees, then we'll have that x radians, because we are converting from degrees to radians, right? It will be equal to 1 degrees, right? Because we now want to know how many radians can give us 1 degree. So this crosses, and then that's 1 is equal to 1 pi is equal to 180x, and that tells us that x is equal to pi over 180. So if you are given an angle in degrees to convert to radians, what you simply do is to multiply by what? Pi over 180. So let's say you are given this angle 150 degrees, and you are asked to convert it to radians. What are you going to do? It's going to be what? 150 multiplied by what? Pi over 180. 0 cancels 0. 15. When 15 divides 3, we have 5. And then when 18 divided by 3, I'm going to have 6, right? So that's 5 over 6 pi radians, right? So that's it. So attempt this, first the video and attempt. So let's say I'm given this in the exam 810 degrees. I asked to convert it to radians. What are you going to have? It's going to be what? 810 multiplied by pi over 180. This cancels this. 9 can go into this to give us what? 9 can go into this to give us 2, and that's 9 over 2 pi. And then attempt this last question, 660. Pause the video, right? It's going to be what? 660 times pi over 180, and then this cancels this. 2 can go here to give 33, and 2 can go here to give 9. 3 can go here to give 3. 3 can go here to give 11. So that's 11 over 3 pi radians, right? So that's it. Very simple. Okay, let's step up. So based on all we've been discussing, we've stated the three trigonometric ratios, the three basic ones: sine, base, sine, cos, and tan. And then we now extended to sec, cosec, and cot. And that's very important because you could be asked to link questions that link these quantities together. So let's say I'm given this. sec x is equal to 2, I asked tan theta for tan theta, where x is acute. So please, it is very important. When you are given something like this, don't just go straight and get the value, because the value of x depends on whether it's acute or obtuse, depends on the range. So if you are told that x is acute, it implies that x is greater than 0 degrees, right? It's in between 0 and 90 degrees. It's greater than 0 but less than 90 degrees, right? But if it's obtuse, that means it's greater than 90 degrees but less than 180 degrees. So in the case of sec x, you have to get what? Tan x. So convert it to the three in terms of the three basic ones, which is sine, cos, and tan. And if you've been paying attention, we said that sec x is equal to what? 1 over what? Cos x. So we have the right to say that since sec x is equal to 2, that means that 2 will be equal to 1 over cos x, which implies that cos x will be equal to what? 1 over 2. So with this, the job is almost done. So you will now compare this with the general formula you know, understanding that cos x is equal to what? Adjacent over what? Hypotenuse. You just draw a small triangle on your paper, right? And then theta, or x, in this case the angle is x, and then 1 is adjacent to x, right? While 2 is the hypotenuse. Are you following? And then you should master the Pythagoras theorem by now. You should have mastered it. And we don't know what this side is, but based on the two other sides we know, we can get it. So that's simply the fact that taking this as c, taking this as a, taking this as b, we can say that c squared is equal to a squared plus b squared, and the fact that 2 squared is equal to 1 squared plus b squared, right? And then if we have this, 2 squared is 4, 1 squared is 1 plus b squared. That's 4 minus 1 is equal to b squared. And that means that b squared is equal to 3. That means that b is the square root of 3, plus or negative. So since it's length, we take just positive root 3. So what we then have now is 2, 1, root 3. So from this now, what is tan x? Tan x is what? Remember, it is the opposite over the what? Adjacent. So that's root 3 over 1. But you don't hurry to pick that, right? It says where x is acute. And I said that if it's acute, it's between 0, that is greater than or equal to 0, and it's less than 90. It's greater than 0, less than 90. And with what I've said earlier, I've said that if it lies between 0 and 90, all are positive. Do you understand? So we have the right to say that tan x is equal to what? Root 3. Do you understand? Because if it's acute, if x is acute, that means it lies between 0 and 90. And between 0 and 90, all the basic trig ratios are positive. Do you understand? So with what I've just explained, I want you to be able to answer this. So let's say I'm given this cosec x is equal to 6 over 5. I ask, what is cos theta? What will be your answer? So what's the first step? Convert it to any of the three basic ones you know. Sine, cos, or tan. That is for this. So cosec x, if you've been paying attention, say that cosec x is equal to 1 over sine x. So since cosec x is equal to 6 over 5, we can therefore say that sine x is equal to what? 5 over 6, and then we can use that to get cos theta now. And then knowing that sine x is equal to the adjacent, the opposite over the hypotenuse, what we then have is constructing a triangle, and then let's call here x, and then here 6, and here 5, because 5 is opposite to x, right? And then what we need to get is here. So using Pythagoras theorem, taking here as c, taking here as a, taking here as b, c squared is equal to a squared plus b squared. So 6 squared is equal to a squared plus 5 squared, right? And that's going to be what? 36 is equal to a squared plus 25. And that's 36 minus 25 is equal to a squared. And that means that a squared is equal to what? 11. That means a is equal to the square root of 11. Do you understand? So we can then redraw the triangle as what? Root 11, right? 5 and then 6. So what is cos theta from here? Remember that cos theta is equal to what? The adjacent over the hypotenuse. The adjacent, so the adjacent theta is in root 11, so that means that cos theta will be equal to root 11 over 6. But if in the exam you were told, okay, so sorry, this is cos x, right? Let's maintain the same angle. This is cos x. So if we were told in the exam that x is obtuse, what will be your response? Right? Will it still be root 11 over 6? So based on what we have, since you are told x is obtuse, that means it's greater than 90 but less than 180. And remember we said from the first quadrant 0 to 90, 90 to 180, 270 to 360. So you can see that if it's obtuse, it lies within this quadrant. Are you following? So its sign is only positive in this region. So if it is obtuse, cos is going to be negative, because cos is only positive between 0 and 90 degrees. That's when that's if it's acute, and then within what? 270 and 360. 270 to 360, which is over here. This is the only region. These are the two regions. Well, any other thing is negative. So it will be wrong if you ask for cos theta and you say root 11, or cos x and you say root 11 over 6. The answer is negative root 11 over 6. That's if x is obtuse, because if x is obtuse, it lies between 90 and 180 degrees. That means x lies within 90 and 180, and only sign is positive in that region. So cos has to be negative. Are you following? Okay, let's take more. So lastly, based on this concept, I want you to answer this. If I give me this in the exam that tan x is equal to 0.8, I ask to find cosec x, what will be your response? So you can see that this is a fraction, is a decimal, right? So 0.8 is same as what? 8 over 10. 2 into itself, 2 into 8 is 4, and then into this is 5, right? So we can see that tan x is equal to 4 over 5. And what is cosec x? Cosec x is equal to 1 over sin x. So if we can determine sin x from this, the job is done. So we simply construct a triangle. Since tan is opposite over adjacent, that means we place 4 here. This is x, this is 5, right? And then what's the hypotenuse? It's simply what? Taking here as c, we have that c squared is equal to a squared plus b squared. So c squared is equal to 4 squared plus 5 squared, which is c squared is equal to 16 plus 25, right? That's c squared equal to 41, and that means that c is the square root of 41. So we could call here square root of 41. And then what is sine x? From this, sine is opposite over adjacent over hypotenuse, sorry. So sin x is opposite over hypotenuse, so that's 4 over root 41. But since we're asked for cosec x, which is 1 over sin x, your final answer will be what? 1 over what? 4 over root 41, which is going to be what? Root 41 over 4. And this answer will be correct if the angle is what? If the angle is obtuse, right? Why is it going to be correct if the angle is obtuse? Because given what is here now, right? With what is given here, you have that tan x is equal to 0.8. And if tan x is positive, right, you may now be told, okay, it's acute. But I don't think x cannot be obtuse, because for x to be obtuse, that means that tan has to be negative, right? Tan has to be negative because tan is only positive within 90 and 180. So within 180 and 270, right? Because 90 to 180 is obtuse, 180 to 270, right? That's where tan is positive. Do you understand? Okay, that's root 41 over 4. So assuming that x is acute, then that means that cosec x is root 41 over 4. Okay. So let's step further to special angles, right? And this is very, very important for the Math 103 exam. And I actually researched and I found out something. Lately you get to the exam, but when you start the exam, you simply draw a table and label here sin theta, cos theta, tan theta, because once you get these angles, the job is done. And then you draw a line, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and let me add 180 here. But we're not focusing on 180 now. So what you simply do is to write from 0 to 4, starting from the left. So that's 0, 1, 2, 3, 4. This is like a trig. And then, but on the row of course, what I'm going to do is 4, 3, 2, 1. Do you understand? And then divide each, right? Divide each. First of all, get the square root of this and divide by 2. Square root of this, divide by 2. The square root of this, divide by 2. The square root of this, divide by 2. The square root of this, divided by 2. Same here. Square root of this, divided by 2. Square root of this, divided by 2. The square root of this, divided by 2. The square root of this, divided by 2. Square root of this, divided by 2. And with this, you've gotten it. Because sin 0 is 0, sin 30 is half, sin 45 is root 2 over 2. Sin 60 is root 3 over 2. Sin 90 is square root of 4 is 2. 2 divided by 2 is what? 1. So how do we get tan theta? Remember when I said, I proved it, that tan theta is equal to what? Sin theta over cos theta. So you divide the sine values by the cos values. So since this is 0 and this is 1, 0 divided by 1 is what? 0. That's, I'm dividing these values by this. And then in this case, you have square root of 1 over 2, which is 1 over 2, and square root of 3 over 2. And if you divide it, what are you going to get? 1 over root 3. If you divide 1 over 2 by root 3 over 2, you're going to get that. And then in case of tan 45 degrees, root 2 divided by 2 divided by root 2 divided by 2 is going to leave us with 1. Right? Tan 45 is 1, right? And then tan 60 will be root 3 over 2 divided by what? 1 over, that's root 1 over 2, which is what? Root 3. And then in this case, root 4 over 2, which is 2 divided by root 0 over 2, which is 0. So if a number divides 0, what's that called? Undefined. So with this, you have that tan 90 is what? Undefined. So this is a way out of the whole thing. Do you understand? And then in the case of sine 180 degrees, right? What you're actually going to do here is that if you're looking for sine 180 degrees, consider the fact that I said that sine theta is equal to what? Cos 90 minus theta. Are you following? So that means that sine 180 will be equal to what? Cos 90 minus 180, which is what? Cos minus 90. And remember that we said that cos of minus theta is cos theta. And from this table, what is cos 90? Is what? 0 over here. So sine 180 is 0. Then in the case of cos 180, remember that cos theta is equal to what? sine 90 minus theta. So that implies that cos 180 is equal to sine 90 minus 180, which is equal to what? Sine of minus 90. And remember, earlier we said that sine of negative theta is equal to negative sine theta. So negative sine 90. From the table, what is sine 90? Sine 90 is 1, right? Sine 90 is 1 because root 4 divided by 2 is 1. And then we have the minus sign over there. So that's minus 1. And then in the last case, if you ask what is tan 180, what's that going to be? So remember that tan theta is equal to what? Sin theta over cos theta. So since sin theta of 180 is 0 and cos theta of 180 is 0, that means that tan theta will be equal to what? Sin 180 over cos 180, and that's 0 over minus 1, which is what? 0. Do you understand? So I believe that if you ask to tackle any problem based on these special angles, you won't have any problem. So let's go right to something more crucial. And then in the case of the sine, cos, and tan formulas. Right? So it's important to know the addition formulas. That's for sine. If you have sine A plus B, it's important to know that sine A plus B is equal to sine A cos B plus cos A sine B. While sine A minus B will be equal to sine A cos B minus cos A sine B. Right? And then in the case of cos, you must be very careful. The signs change, right? It's going to be what? Cos A cos B negative sine A sine B. And then for cos A negative B, the sign's going to change. It's going to be cos A cos B plus cos. That's plus sine B of sine A. You can see sine A sine B or sine B sine A. Any is correct. Plus sine A sine B, right? So you can notice what's happening here. In the case of the sine addition, you can see that it's a mixture of sine and cos, right? Sine A cos B, cos A sine B, and then this it's following the sign in between. Following the sign in between, sine A cos B minus cos A. But in the case of cos, you can see that all of them are grouped. Cos is on one side, sine is on another side. There is no mixture. So you just cos A cos B, sine A sine B, cos A cos B plus. And you can see that when it's negative, it becomes what? Positive. So please, I want us to apply this formula, and then before I go to that, it's also important that I know the tan formula. The tan formula is, if you have tan into A plus B, it's equal to what? Tan A plus tan B over 1 minus tan A tan B. So on the denominator, you will now change the sign. And then in the case of tan A minus B, what you have is tan A minus tan B all over 1 plus tan A tan B. So taking into considerations the special angles we looked at, it is important to note that we now have to apply these formulas to solve them. So let's say I ask this in exam, cos 75 degrees, and you ask to express it in solved form. You have to think, look at the number given to you. Having known the special angles 0, 30 degrees, 45 degrees, 90 degrees, 180, 0. So the question now is, I need just two combinations such that when I add or subtract, I can get what? 75, right? And then it's a mixture of special angles. And that's very simple. 45 plus 30 is what? 75. 45 is the special angle, 30 is the special angle, right? So we can simply write cos 75 as what? Cos 30 plus what? 35 plus 45. And then applying the cosine rule that says that cos A plus B is equal to cos A cos B minus sine A sine B. What we're going to have here is the fact that cos 30 plus 45, which is same as cos 75, will be equal to what? Cos 30 cos 45 minus sine 30 sine 45. And then if you've mastered the angles, you know that cos 30 is same as sine 60, which is what? Cos 30 is root 3 over 2. Cos 45 is what? 1 over root 2, which is still root 2 over 2. And then negative sine 30 is half. Sine 45 is 1 over root 2, which is still root 2 over 2 by rationalization. So we can write this as root 2 over 2, root 3 over 2 times root 2 over 2, which is 1 over root 2, minus 1 over 2 times 1 over root 2 is what? Root 2 over 2, because if we should rationalize, look over here, it's going to be times root 2 over root 2, and root 2 times root 2 is what? 2, right? So what we're then going to have here is the fact that on simplification, root 3 times root 2, using stored properties, we have that square root of a times square root of b is equal to the square root of ab. That will be the square root of 6 over 4 minus root 2 over 4. And we can factor out something here, right? And that's the fact that 1 over 4 is common, so that's 1 over 4 into root 6 minus what? Root 2. And this is the value of cos 75 degrees. And looking at it, you can see that we are asked for cos 75. And what did we say when the angle is within 0 and 90 degrees? Cos will be positive. So if you are even seeing negative answers, you have already eliminated them. So I want you to pause the video and attempt this question. So let's say you are given this in the exam. And it says sec 15 degrees. Pause the video and attempt. It asks what is sec 15 degrees in solid form. And that's simply going to be what? Expressing it in terms of what? The complex, the special angles, right? And in this case, you can use 45 and 30. That's 45 minus 30. So that is what? Sec 45 minus 30. But I didn't give you any formula for this, right? So knowing that sec x is equal to what? 1 over cos x. That means that sec 15 is equal to what? 1 over cos 15. So if we can get cos 15, which is equal to cos 45 minus 30, then the job is done. So according to the cos formula, cos A minus B is equal to cos A cos B plus, remember the sign is going to change, plus cos sin A sin B. So in the case of cos 45 minus 30, we're going to have cos 45 cos 30 plus sin 45 sin 30, right? And cos 45, we've established that is root 2 over 2 times. Cos 30 is root 3 over 2. Then plus sin 45 is still root 2 over 2. And then this is half, right? So that's going to be what? Root 6 over 2 over 4. Because 2 times 2 is 4, right? Plus root 2 over 4. And what's that going to be? 1 over 4 into root 6 plus root 2. And this is the value of sec 15 degrees. Understood? And then to apply the tan formula, I want you to pause the video and attempt this. If you are asked for the value of tan 105, what possible combination can you bring together that's made up of the special angles that's going to give you what? 105. It may be more than one, it depends on what you want. I guess 60 degrees and 45 degrees, because 60 plus 45 is what? 105. So we can say tan of 60 plus 45. And using the general formula that says that tan A plus B is equal to what? Tan A plus tan B all over 1 minus tan A tan B. All I'm then going to have is, in this case of tan 60 plus 45, it will be what? Tan 60 plus tan 45 all over 1 minus tan 60 tan 45. Because the sign is going to change, right? So tan 60 is what? from the table that I drew earlier, tan 60 is equal to root 3 and tan 45 is equal to 1, right? And then all over 1 negative tan 60 we said is root 3 and tan 45 is what? 1. So what we're then going to have is root 3 plus 1 all over what? 1 minus root 3. And we can actually rationalize this, right? By multiplying up and down by the conjugate of the base, which is 1 plus root 3, 1 plus root 3. Do you agree? So if we start multiplying the numerator, that will be root 3 plus 1 into 1 plus root 3. And this, you have 1 times root 3 is root 3 plus 1 times 1 is what? 1 plus root 3 times root 3 is what? Is going to give us 3. And then 1 times root 3 is what? Root 3. So at the end of the day, that is 1 plus 3 is 4. Root 3 plus root 3 is what? 2 root 3. And then remember that there is a denominator. And what does the denominator bear? 1 negative root 3 into what? 1 plus root 3. And then this times this is what? 1. This times this, that's negative root 3. This times this, that's positive root 3. And negative root 3 times root 3 is going to give us negative 3, right? And that is, this cancels this, and then you have negative 2. So numerator, on simplification, we had 4 plus 2 root 3, and then divided by negative 2. And with that, we can divide through each part by negative 2. That will be 4 over negative 2 plus 2 root 3 over negative 2. And what's this going to be? That's going to be negative 2 negative root 3. We can actually factorize this to be negative 2 negative bracket 2 plus what? Root 3, because that's kind of like factoring with negative 1. Are you following? That's negative bracket 2 plus root 3. Then lastly, so that you master it, we asked for the value of cos 165 in the exam. How will we go about it? So what are the possible combinations you could take? Maybe with remember, these are the special angles we have: 30, 60, 90, 180. So what possible combination can we use? And we also have 45 degrees. So if we should subtract this, right, this is going to give us what? 120. So essentially what we need here is if we can take that of 90 and let's say 75, right? 90 and 75. So this is actually compound in nature. It's actually compound. So how do you go about it? So what happens here is that we then have cos of 90 plus 75, right? So you have to be fast. And remember that is going to be what? Cos 90 cos 75 minus, because there's a plus here, sign will change, and that will be negative sine 90 sine 75. And you know that cos 90 is 0, right? So the whole of this is off. And remember that sine 90 is 1, right? So it's negative sine 75. And you can see that this is not going to help us. So we now have to split this again, right, into another set of special angles. That's negative sine of 45 plus 30. And what is sine 75? According to the sine formula that says that sine A plus B is equal to sine A cos B plus cos A sine B. What are we then going to have? Remember, there's a negative at the back, right? So let's keep the negative for later. So that will be sine 45 cos 30 plus cos 45 sine 30, right? And sine 45 is what? Is root 2 over 2 multiplied by cos 30, which is what? Root 3 over 2 plus cos 45, which is root 2 over 2 times half, right? And then that's going to be root 6 over 4 plus root 2 over 4, and then remember that there is a negative, so that's going to be negative 1 over 4 into root 6 plus root 2, and that is the value. And looking at what you have, you can see that is what cos 165, right? And 165 lies between where and where? 180 and 270, and within 180 and 270 is only term that is positive. Cos is positive within 270 and what? And 360. So that is why you expect a negative answer. So these things can actually help you to even have an idea of if you are even getting it or you are missing it, right? And then on further application of this, right? Further application of this, let's say you have sine A to be equal to 4 over 5 and cos B to be equal to 12 over 13. Let me use capital letters. And the question says A and B are acute. And then it says find cos A plus B. Right? So if I have to find cos A plus B, what's it going to be? Cos A cos B minus sine A sine B. Right? So we have the value of cos B, but we don't have the value of cos A. So the only way to get cos A is from sine A. And it's the fact that sine A is what? 4 over 5. So we have to draw triangles here. So since sine A, this is the angle A, opposite over hypotenuse, that's for sine A. And then for cos B, we had that it's 12 over 13. That's adjacent. Let's call here B and then 13, right? And then using Pythagoras theorem, we can get this side, right? Here will be 3, here will be 5. I hope you are not lost, because in the case of 5 and 4, you have that 5 squared is equal to 4 squared plus x squared, and 5 squared minus 4 squared is what? Is 9. Square root of 9 is 3, and in this case 13 squared minus 12 squared is what? 25. Square root of 25 is what? 5. That's how this side came about. So with this, we then substitute into the formula that says cos A cos B minus sine A sine B. So cos A is what? What is cos A? Cos A is going to be 3 over 5 because this is adjacent to A. So that will be 3 over 5 multiplied by, what is cos B? Cos B is what? 5 over 13. Are you following? And then plus, excuse me, what is cos B? Cos B is 12 over 13. Right? Because this is adjacent, right? And then this is the hypotenuse. And then plus, sorry, the formula is cos A cos B minus sine A sine B. So what we have is cos A 3 over 5 times 12 over 13 minus sine A, which is what? 4 over 5. It was given in the question, times sine B. So from this triangle, what is sine B? Sine B is the opposite over the hypotenuse, which is what? 5 over 13. Are you following? So with this, what do you have? You have that 36 over 5 times 13 is 65 minus 20 over 65, and that's going to be what? That's going to be 16 all over 65, and that's the value of cos A plus B, because cos A, we got it as, that was 3 over 5, cos B 12 over 13, right? And that's 36 over 65 minus sine A, which is 4 over 5, times sine B, which is 5 over 13, and that's 20 over 65. That's 16 over 65. So that's the value. So you should be able to apply these laws. Do you get? So based on what I've just explained, if you are given sine alpha equal to 3 over 5, right, and tan beta equal to 5 over 12, where alpha is obtuse and beta is acute. If you're asked this in exam, you must be very careful. And then the question says, find sine alpha plus beta. What's the formula? Sine alpha cos beta plus cos alpha sine beta. Simple. But you must now be very careful with these values, stuff like that. So sine, remember that if it's obtuse, it lies between 90 and 180, and if it lies between that point, that means sine is positive. Do you understand? So we then need to get the value of sine alpha, which we've got, that's already been given to us. That means we have to get value of cos alpha, right? So since sine alpha is 3 over 5, we can draw a triangle. Sine alpha is 3 over 5. So here is 3, here is 5, right? That means here is 4, because 5 squared minus 3 squared is 16. Square root of 16 is what? 4. So with this we can say that cos alpha is what? What's the adjacent? 4, right? And the hypotenuse is what? 5. And then the second triangle will be based on tan. So I was given that tan is 5 over 12, right? So that means that the opposite is 5, and that's for beta, right? 5. The adjacent is 12, and then what is here is 13, because 5 squared plus 12 squared is 169. Square root of 169 is what? 13. So we can comfortably say that what do we need from here? Tan beta. We need the value of cos beta and we need the value of sine beta. So cos beta is equal to 12 over 13, while sine beta is equal to what? 5 over 13, which is opposite over what? Hypotenuse. So with this we can then substitute into the formula, right? Remember that this was sine alpha cos beta plus cos alpha sine beta. So what is sine alpha? It was given in the question as 3 over 5 multiplied by what? Cos beta multiplied by cos beta. And what is cos beta? 12 over 13. But you must be careful here. You must be careful here, right? What does the question say? Alpha is obtuse and beta is acute. So cos beta being positive is not a problem, right? Because if beta should be acute, between 0 and 90 everything is positive, so there is no issue here. But coming to cos alpha, which is 4 over 5, it will be wrong for you to just write 4 over 5. That would be wrong. That's why you must be careful, because sine alpha is what? 3 over 5, and alpha is obtuse, and cos is not positive where you have an obtuse space, because obtuse is 90 to 180, cos accepts from 270 to 370 as positive. So what you are going to record here is what? Negative 4 over 5, since alpha is obtuse. So multiply by what? Sine beta, which is 5 over 13. Are you following? So that's 36 all over 65 minus 20 over 65, which is what? 16 over 65. And that's sine alpha plus beta. So if you made the mistake of using plus, what are you going to be getting? Going to be 56 over 65, and I bet you are going to see it. Do you understand? So don't make that mistake. What you're going to use is what? Negative, right? Okay. So let's move further. So let's move to solving trig equations. Very, very crucial. Very crucial. So important thing here is that you should know how to interpret the intervals or the domain that's given to you. For example, they could ask you this question in exam: sin x is equal to half, and then you may now see something like this: 0 less than x less than pi, right? So you must be very careful when you are given this kind of intervals, because some students will just rush and say, okay, x will be equal to the sine inverse of 1 over 2, and then quickly say 30 degrees. But it's not only one solution it has, because from the 4 quadrants we have A, C, T, S. Sine is positive within 90 and what? 180 degrees. So it's not only 30 that's going to make it positive as half. Are you following? So in this case now, you are given this interval. That means the value of x should lie between 0 and pi. And you can see that the angle is now expressed in radians. Are you following? It's now expressed in radians. So if you should convert 30 degrees with what I explained later, earlier, to convert 30 degrees to radians, what are we going to have? 30 times what? Pi over what? 180. This cancels this. You are left with what? Pi over 6, because 18 divided by 3 is what? Is 6. And pi over 6 lies within this range, right? But that's not the only solution. Do you get? That's not the only solution. That is why I've come to this point. This is the first quadrant, this is the second, this is the third, this is the fourth. Values here 0 to 90. But if you want to get what is here, what you have to do is what? 180 minus theta. Right? Over here, 180 plus theta, and over here, 360 minus theta. Because we are trying to say that even though we should have that 30 degrees, it's possible, right? Here is 150, right? You get? And in this case, even though we have this, this is like this, right? So it's going to be 180 plus this theta. Do you understand? Okay, let's see how we can do that. So in the second case, since sine is also positive in the second quadrant between 90 and 180, which is acceptable by this interval. Are you following? Which is acceptable by this, because pi is 180 degrees. Oh, I hope you know. To convert pi to degrees, pi times 180 over pi, which is what? 180 degrees. Are you following? So if we now add 180 to 30 degrees, what is 180 plus 30? Is what? 210. I hope you know I'm adding 180, because this, that's, we are talking of tan, right? What we are looking at is sine. Are you following? So since we are looking at sine, which is between 90 and 180, we are going to do what? Subtract according to what I said. Since it's in the second quadrant, 180 minus theta. So 180 minus 30, which is what? 150. So what we now have to convert this to radians to be what? 150 times pi over what? 180. This cancels this. 3 into here 5, 3 into here 6. So you have 5 over 6 pi. So these are the two solutions within 0 and what? 180 degrees. But if maybe the question said 0 less than x less than pi over 2. Remember, pi over 2 now be what? Pi over 2 times 180 over pi, which is 90 degrees. Your answer will just stop here. Okay, let's take more so that you have a clearer understanding. So let's say I'm given this question. Tan theta is equal to 3 over 4. 3 pi over 2 less than theta less than 2 pi. You should be able to interpret this. What's the meaning of this? It simply implies that theta is greater than what? 3 pi over 2 or less than what? 2 pi. And what is 3 pi over 2 in degrees? 3 pi over 2 times what? Pi over what? Times 180 over pi. Right? And that is what? 270 degrees. And then 2 pi is what? 2 pi times 180 over pi, which is what? 360. So we can literally say within this range, 270 to 360, if tan theta is 3 over 4, the question now said find sec theta. Find sec theta. You now must be very careful. Do you understand? What is sec theta? Remember that sec theta is equal to what? 1 over cos theta. So since tan theta is equal to 3 over 4, we can draw a triangle. Remembering that tan theta is equal to opposite over adjacent. Here is the theta, here is 3, here is 4, because this is opposite, this is adjacent. And then to get the hypotenuse, we use Pythagoras theorem, and that's going to be 5. Because 3 squared plus 4 squared is 25. Square root of 25 is what? 5. So from here now, what is cos theta? Remember that cos theta is equal to adjacent by hypotenuse. So it's going to be what? 4/5. But we are looking for what? Sec theta. So if cos theta is 4/5, that means that sec theta is what? 5/4. But this is not the final answer. Because if tan theta, right? Look, if you look at the range that is given to us, 270 to 360, and from the quadrants I drew earlier, what did I say? I said that between 270 and 360, tan is positive. Do you agree? That's what I said. Between that range, tan is positive. I used illustrated using ACTS to help you remember it, so that you don't mix it up. So since tan is the only trig ratio that is positive, all others will be negative. So that means since it is that way, 270 to 360, and cos is negative in this region, that means that cos theta would be what? Negative 4/5. You attach a negative sign. Calculate normally, but at the end of the day, you now know whether it should be negative or positive based on the range given to you. Are you following? So this is what sec theta is what? Negative 5/4. So saying that sec theta is equal to 5/4 is wrong, because the range given to you is only looking at values between 270 and what? 360. Okay, we are almost done. So let's say you are given this in the exam: 2 cos square theta plus cos theta minus 1 equals to 0, and the range is given to you: 0 less than or equal to theta less than 5/2. So you can apply a quadratic technique here by saying let cos theta be equal to, let's say, a. We now have that 2a squared plus a minus 1 is equal to 0. Then by factorization, do for two numbers that you multiply, that will give you minus 2, and that you add, that will give you what? Plus a. And that's simply what? 2a and minus a. 2a minus a minus 1 equal to 0. That will be 2a into a plus 1 minus 1 into a plus 1 by factorization. And then we have that 2a negative 1 into a plus 1 is equal to 0. And then 2a minus 1 is equal to 0, or a plus 1 is equal to 0. When this crosses, 2a is equal to 1, or a is equal to minus 1. That means a is half, or what? Minus 1. And then you now recall that cos theta is equal to a. So cos theta is equal to 1/2, or cos theta is equal to what? Minus 1. So the question now is, what is the cos inverse of what? Half. But make sure you pay attention to the range given to you. Pay attention. What's the range given? You are looking at values between what? Greater than or equal to 0, but less than what? 90 degrees. Because what is here is what? Pi/2. Are you following? So cos inverse of half, that's cos inverse of 0.5, is going to be what? It's going to be 60 degrees. Because remember that cos 60 is what? 0.5. But cos inverse of 0.1, of negative 1, sorry, is what? 180 degrees. If you're paying attention from that table we constructed, cos inverse of negative, because cos 180 is what? Minus 1. But this will not be included in the answers because it is not within the range. We are only looking at values within 0 and 90. Are you following? So that answer will not be accepted. Do you understand? And cos cannot be negative within 0 and what? 90. So there is no answer. Are you following? So this is 60 degrees, and then if you want to convert it to radians, to be what? 60 times what? Pi/180. This cancels this, and what you have is what? Pi/3. That is the solution. So with what I have just explained, I want you to attempt this question. So let's say you are given this in the exam. 2 cos square theta minus sin theta minus 1 equal to 0. And the range given to you is 0 less than or equal to theta less than 2 pi. And you have to solve for theta. You can see that what is here is cos square theta, what is here is sin theta. You now have to remember the quantity that says that what sin square theta plus cos square theta is equal to what? 1. So you can therefore say that cos square theta is equal to what? 1 minus sin square theta. Right? And then that's 2 into 1 minus sin square theta minus sin theta minus 1, right? And that will be 2 minus 2 sin square theta minus sin theta minus 1 equals to 0. And then 2 minus 1 is what? 1, right? So that will be negative 2 sin square theta minus sin theta plus 1 equals to 0. We can multiply through by the negative sign, and then we have 2 sin square theta plus sin theta minus 1 equals to 0. We can now say let sin theta be equal to b. That will be 2b squared plus b minus 1 equal to 0. You look for two numbers you add that will give you negative, that will give you positive b. You multiply, that will give you negative 2b squared, and that's simply 2b and negative b, right? And that will be 2b into b plus 1 minus 1 into b plus 1 equal to 0. And that will be 2b minus 1 into b plus 1 equal to 0, right? And that implies that b is equal to half, or b is equal to what? Minus 1. Are you following? And then you now have that sin theta will be equal to what? Half, or what? Sin theta will be equal to minus 1. And look at the range that was given from 0 towards 2 pi. So you have to get all the answers. So first of all, sine inverse of half is what? The first one is 30 degrees. You know that one. But that is not where it ends. You now look for other regions where sine is positive, because this thing is positive. This is the sine is a positive answer. So sine is positive in first and second quadrants. Are you following? Sine is positive in that region. So what you're then going to have here is what? 180 minus 30, which is what? 150 degrees. These are the only two possible answers. That is in this section, because these are the only two values for which sine is positive. But if we now consider the other one, which is sin theta equal to negative 1, what are we then going to have? That is the sine inverse of negative 1. So we now have to check where is sine negative, right? Sine is negative in the third and fourth quadrants, right? The sine inverse of 1 is what? 90 degrees, right? So for it to be negative, line between 180, this is third quadrant, right? Third quadrant is 180 to 270. I remember I said in the third quadrant you simply add 180 to the desired angle. Do you understand? So that will be 180 plus 90, which is what? 270 degrees. And then also remember that at what do you call it? Cos, that is at the fourth quadrant between 270 and 360. Sine is also what? Negative. And what will you do there? 360 minus theta. And 360 minus 90 is still 270. So you can see that there is a balanced ground there. So it's what? 270. The answer to this is what? 30 degrees, 150 degrees, and what? 270 degrees. Because at 30 degrees and 150 degrees, the output is what? Half. These are positive. Then at only this value, because we just use the fact that sin 90 is 1, and that for this value to be negative, it has to lie in the third or the fourth quadrant, and we're able to now get it. Are you following? Okay, so that's it. So right for that, so I want us to go to another level, and then please, with all of this that I've mentioned, you should also be able to apply things like this, just like when we said cos square theta plus sin square theta is equal to 1. you should also be able to apply 1 plus tan square theta equal to what? Sec square theta. Just like in this question, I will not solve it, right? So that this video would. It's the same principle. So what I'm going to say here is that 1 plus tan square theta is what? Sec square theta. So you replace this with 1 plus tan and then solve the quadratic equation. Are you following? And then let's look at sign of large values. When the sign value is large and they are like, which of this is equal to this? How do you tackle such questions? Right? So this is the plane, and then clockwise is a total of what? 360 degrees, which is equal to 2 pi radians. Agreed? So in the exam, they could ask you which of this is equivalent to cos 840 degrees. And the options now may be negative sine 30, option B, sine 60, option C, minus cos 120, and let's say option D, cos 60. So what's the best way to go about this? This is actually like a revolution. So if this is 840, what happens? It goes around the first time 360, right? Another 360, that is 360 plus 360, which is what? 720. Remaining what? 120. So after going around twice, it will now return to what? It will now land at what? 120. So that means that cos 840 is same as what? Cos 120. So the question now is, which of this is equivalent to cos 120? Are you following? Which of this is equivalent to cos 120? And then remember what we said, that cos theta will be equal to what? Sine 90 minus theta. That's where all these things apply. So that will be cos 120 is equal to sine 90 minus 120, which is what? Sine minus 30. And remember that sine of minus theta is minus sine theta. So that's minus sine 30. Do you understand? So the answer is A. Let's take this question. Let's say you are asked to get the value of cos 1600. And they say which of these is equivalent. What do? The base of all I've been explaining is divide the answer by what? 360. If this cancels this, you have 36. What is the closest to this? It is 4, because 36 times 4 is what? 144. Do you agree? 36 times 4 is 144. So what is left? That will be 160 as we divided it. Let me write it down again, that it will be clear. Alright, 160 divided by 36 is going to give us what? It's going to give us 4, which is 144, right? So that will be 4 remainder what? 16, right? So you have 16 degrees left. Are you following? 16 degrees left. So it's very simple. What you now have is what? Cos 16. Do you understand? So cos 16 is the answer. Because 1600 over 360, that means it will go around the circle 4 times. After going around 4 times, 360 multiplied by 4 is what? 4 here, that will be what? 4 carrying 2, and that will be what? 1440. Are you following? So what is remaining? That is the question. Do you understand? So what is remaining? So what happens here is that you have 1600 divided by 360, and what you now have is what? 4. And 360 times 4 is 1440. So remainder what? 160 degrees. So you have what? Cos 160 degrees. And cos 160 is the same as what? Sine 90 minus 160. which is what? Sine minus 70, which is what? Minus sine 70 degrees, right? Minus sine 70 degrees. So this, the mistake here was that we're dividing 160 by, but 1600 divided by 360, right? Which with this will give you 4, and then the remainder will give you 160 because 0 will be carried over, right? So that's minus sine 70. So lastly, let's take this question. If you are given sine 1900 and it says equal to cos x, what do? Divide 1900 by 360. And what's that going to be? It's going to be what? 336 divided by 190 is going to be what? It's going to be 5. So what you now do is to multiply 360 by 5. So 360 times 5 is going to be what? 1800. So remainder what? 100 degrees. So that means that it is same as what? Sine 100. Sine 1900 is same as what? Sine 100 degrees. And then using the fact that sine theta is equal to cos, that's cos theta is equal to sine 90 minus theta, we can therefore say that sine 100 is equal to what? Cos 90 minus 100. First of all, we have that sine theta is equal to cos 90 minus theta, and the fact that cos theta is sine 90 minus theta, right? So that's sine 100 will be equal to cos 90 minus 100, which is what? Cos minus 10. And remember the cos of negative theta is what? Cos theta. So we have what? Cos 10 degrees. So that means x is 10 degrees, right? And that'll be all for this video. Thank you so much for watching, and I believe that any question that comes up on trig, you should be able to answer it with accuracy. Thank you so much. Please do well to like, share this video, subscribe. My number is on the screen. If you have any questions that concern this, do well to contact and ask. Thank you so much once again, and have a nice day.